to actually set up long division. In this, we have what we call the dividend and then the divisor. Do you guys remember from those two numbers which would be considered the divisor? I feel like this is vocab, it doesn't really get talked about much. You got a 50-50 shot of being right. Peyton?
3.
It's the 3, yeah. So this is called the dividend, right here. And again, if you want to wait and write this with the longer polynomial division, you can, but that's the dividend and this is the divisor. And I point that out because the idea is the divisor is always going into the dividend. And when you learned long division in elementary school, maybe your teacher referred to it as like the house, like which number goes inside the house. Sometimes teachers use that, but it looks like this, 3 going into 2,965. So now what? Well, now we try to go in step by step each digit into 2,965, but can 3 divide into 2?
No.
No, so when that happens, we jump to all of 29 and we ask ourselves, okay, how many times can 3 fit into 29? 9 times, right? Now because it's going into all of 29, you're going to put that 9 above the second digit. So notice what I'm doing, I'm saying this goes in 9 times to that whole quantity, whereas if it was for the first digit, you would have put it here, right? So it's all about keeping this nice and orderly. Great. Then we do 9 times 3, which is 27. And then what's the next step? Subtract. Good. We pull down the 6, showing that we're moving over to the next place value. 29 minus 27 is 2. So now we ask ourselves, how many times can 3 fit into 26?
8.
8 times. So 8 goes up here. Again, we multiply. 3 times 8 is 24. Subtract. That gives us 2. Now we pull down the 5. And how many times can 3 fit into 25?
8.
Again, 8 times, exactly. And so we get 24, and here's our remainder. So here's the catch. This is not perfect division because there's a quantity left over. There's 1 left over. Does anyone remember how we kind of format that in our answer, Malachi? It's 1/3 because the idea is that this is still out of the original divisor. So the way you'd finally answer this problem is you would say, okay, that equals 988 with a remainder of 1/3. Good, you guys. I prefer fractions because they're more precise, but yes, it would be 0.3 repeating. Yeah. Potentially when you like very first learned this, you maybe would have seen a teacher write it like this, like with a remainder of 1, but it's much more proper to write it as 1/3. Understanding that 1 is still a quantity being divided by 3, we just can't actually take that value. Okay, so I review that because what we're going to learn today is that you can actually perform polynomial division in the same way. So I realize my resters can't see this, but I'll write it on the TV shortly. This asks us to divide 2x to the 4th plus 3x cubed plus 5x minus 1 by a divisor of x squared plus 3x plus 2. And we're going to perform this as long division. Okay, so here is the problem that we are given. Again, understanding in terms of setup, which polynomial is going to go where. This is our divisor, so it's going to sit outside. This is our dividend, so it's going to go on the inside. It's all about order. Now I have a little note written up here that I went ahead and left from the last time I did these notes. When we do these problems, you have to check to see if both the divisor and the dividend descend perfectly by degree. Now, what do I mean by that? Well, if you look at the dividend here, the first term is degree 4, the next term is degree 3, and then it skips to degree 1. So in that, technically the degree 2 term is missing. Because of that, we need to add in almost like a placeholder value for the missing degree term so that as we start performing our division, you're going to see because we are working with actual variables that we need to have our like terms stacked, which doesn't translate to just straight numbers, but with polynomials is necessary. So here is what I mean by that. As we set up this problem, I'm actually going to move these words above so I have some space to write this. What I need to do is insert essentially a 0x squared term. So we're going to insert whatever is missing because these have to descend perfectly by degree. This is needed for that criteria to be met. so that as we begin dividing, those like terms get stacked and we're allowed to actually perform the subtraction step by step, place by place. So here's how we'll set the problem up. We're going to be dividing x squared plus 3x plus 2 into, and these are going to be long division problems. In fact, I can write that even a little bit neater for us. Here we go. Into 2x to the 4th plus 3x cubed plus that 0x squared term plus 5x minus 1. So that is how this type of problem gets set up. Yes?
When are we ever going to use this?
You probably won't. That's my honest answer. This is one of those things where I'm teaching you to think kind of abstractly, to problem solve. So my belief is that in teaching you this skill, you're learning how to problem solve more than anything. But for those of you who choose to pursue like pre-calc and calculus, you'll be doing simplification of polynomials that will require this. Yeah. So if that feels frustrating this morning, I get it.
Well, I mean, just like work-wise, does anyone ever use this in their future?
Yeah, but at the same time, and here's the thing with all the math you learn in high school, your teachers are very aware that there are calculators that exist that can do this for you. But the thing is, if you don't understand the process of how it works, then that doesn't really benefit you in the long run. So yeah, you could definitely use a calculator to perform this, but this is helping you understand why you get the answers that you get. Yeah. Okay, so setting this up, because we're putting a trinomial into a 5-part polynomial, kind of like when we do the elementary long division, you ask yourself, I think at the beginning it was, can 3 fit into 2? Because this is a 3-termed expression, we're going to start by dividing it into the initial first 3 terms. What we really only care about though is the term that's in position 1. So let's pay attention to what's in position 1, which here is x squared. We want to ask ourselves, what times x squared would give us exactly 2x to the 4th? Because we understand once we find that product, you're subtracting to try to cancel out that digit. So here is our question. X squared times what would give us 2x to the 4th for step 1? Okay?
2x squared.
2x squared, exactly. Now because we're putting the 3 parts into the initial 3 parts, our first digit's gonna go right here, okay? So above the 3rd position. So here's what we're gonna write. We're going to understand that 2x squared is what is needed to multiply by x squared to then get 2x to the 4th. So I'm going to multiply 2x squared times x squared, which is 2x to the 4th, 2x squared times 3x, which is 6x cubed, and 2x squared times 2, which is 4x squared. Now, because I was intentional to set this up by putting in that placeholder here for the missing x squared term, what I have are like terms stacked, because the next part of division is that you subtract. And the only way you could actually perform that subtraction is if you had like terms, because only like terms can be added or subtracted. So now I'm subtracting. I'm always really cautious to put in those parentheses, because we talked Tuesday about how it's easy to forget that you're going back to that act of subtraction. But here was the whole purpose in asking ourselves, x squared times what is 2x to the 4th? These are now going to cancel out because they're the exact same. So 2x to the 4th minus 2x to the 4th cancels. And then 3x cubed minus 6x cubed is a negative 3x cubed. 0x squared minus 4x squared is a negative 4x squared. And then we carry down the plus 5x. And now we just repeat that process. So now, instead of asking ourselves x squared times what is 2x to the 4th, now we say x squared times what is negative 3x cubed. So x squared.
3x.
So now we need to multiply that by a negative 3x to eliminate, again, that first term.
Wait, it has to be positive 3x. Never mind.
No, we want it to be negative, because then you're going to be doing subtraction, and so those double negatives will make it addition, and then they'll cancel. So now I'm multiplying negative 3x times x squared, which is negative 3x cubed. We wanted those to match, so we succeeded there. negative 3x times 3x is a negative 9x squared. And then negative 3x times 2 is a negative 6x. Minus parentheses, making sure we close those. And now we can find that difference. Again, please be super conscientious about adding your subtraction symbol and then the parentheses. That's going to really help eliminate room for error. So these things cancel, negative 3x cubed minus a negative 3x cubed. Then we have negative 4x squared minus a negative 9x squared. That becomes a positive 5x squared. And then 5x minus a negative 6x is a positive 11x. And then we can carry down our last digit, which is the negative 1, or the last term, I should say. And so now, the last question we're going to ask ourselves is, what would we need to multiply x squared by to get 5x squared?
5.
Yep. So then we have a positive 5 up here, and we repeat that process just one more time. So 5 times x squared is 5x squared. 5 times 3x is 15x. 5 times 2, positive 10. Minus parentheses, find the difference. So to finish this off, 5x squared minus 5x squared goes away. 11x minus 15x is a negative 4x. And then negative 1 minus 10 is negative 11. This is now our remainder. So this is what's left over. We cannot go past this. It's not like we could add a decimal to keep going, right? Because these are just polynomials with certain terms. So here's how you then format your solution. What we say is, okay, the quotient of these two polynomials is equal to 2x squared minus 3x plus 5 plus a remainder of negative 4x minus 11, which is still being divided by that divisor, x squared plus 3x plus 2. And that is our final answer. So just like we formatted the remainder in the kind of elementary school review as a 1/3 fraction, this is also a fraction showing that this actually can't be simplified. Those things can't divide into each other, but it is still part of our solution. So that's the gist. I'm gonna do one more for you guys, and I'm gonna have you try one on your own. And I'll do the next one a little bit quicker now that we kind of understand the process of how these things get set up. Example 2 here, we are being asked to divide, I'll write it out here, x to the 4th plus 2x squared minus x plus 5, and we're going to divide that by x squared minus x plus 1. Remember the first step. Look at both your dividend and your divisor to see, do these things descend perfectly by degree? Do we see that we are missing any degreed term in either the dividend or divisor?
Yeah, the divisor. The white
Caleb?
that's the divisor.
The cube root.
Yeah, we need the power of 3 on the first one on the dividend. So we need to insert here a 0x cubed. Yeah.
If the other one didn't have it in order, would you have to do it with the divisor too?
Yeah, you would. You'd have to do it for both. And I
You always
realized
do plus or minus 0x cubed.
plus. Yeah, you're adding in a positive. Not that it really makes a difference though, because 0 is 0 no matter what. But traditionally we write it as plus. So now here's what this problem will look like. We're going to be taking x squared minus x plus 1, and we're going to divide that into x to the 4th plus 2x squared minus x plus, oh no, see I made a mistake, I forgot the cubic term. Gotta be really cautious there. So plus 0x cubed plus 2x squared minus x plus 5. So that's just the setup part. Again, ensuring that we add in those placeholders if any terms are missing. But coincidentally, I guess I didn't mean to do this. I gave you another case where we're dividing a trinomial into something much larger. So you're beginning with the first 3 terms for both of these. Therefore, your question is this: x squared times what is x to the 4th? What do you guys think? Isaac? What do you, x squared, good. And that's going to go above the x squared term here. 3 digits, so 3 spaces over, or 3 terms. Okay, now we start finding those products. So x squared times x squared is x to the 4th. X squared times negative x would be negative x cubed. X squared times 1 is a positive x squared. Minus, parentheses, find the difference. So the x to the 4th powers will cancel. 0 minus a negative x cubed makes this a positive x cubed. Please pay close attention to your signs there and make sure you write it as a positive. And then 2x squared minus x squared is a positive 1x squared. And then we pull down our negative x. So this one's a lot simpler in terms of we primarily have coefficients here of 1. Next step, x squared times what would give us x cubed? What do we think? Just x, right? So we've got a positive x up here. So again, we're going to find those products. X times x squared is x cubed. X times negative x is a negative x squared. And then x times 1 is positive x. Subtract, parentheses, find the difference. So here our x cubes cancel. X squared minus a negative x squared is a positive 2x squared. Negative x minus x is a negative 2x. Bring down our positive 5, and now we're at the last step. So our final question for ourselves is x squared times what would give us 2x squared? Well, that would just be a positive 2. All we need here is the correct coefficient. So to multiply then, we get 2x squared minus 2x plus 2, subtract parentheses, and then find the difference just one last time. So the 2x squared terms cancel. Negative 2x minus a negative 2x, bless you, actually also cancels. And so all we're left with is 5 minus 2, which is 3, and this again is our remainder. So without me actually giving you the final answer yet, why don't you take a second and try to format how you think we would state the answer based on what I did in example 1. So the solution and then including the remainder, and then I'll put it up here in a second and you can see if you did it correctly. So the correct way to do this would be to finish this off by answering that we have a solution of x squared plus x plus 2 plus a remainder of 3 out of the initial x squared minus x plus 1. That's how you would formulate your solution.
If the remainder was a negative, would you just subtract the whole thing from it?
That's a great question. Yeah, so actually we had a negative one here and I didn't talk about it. I meant to. Although they're both, it gets a little finicky. So when you have more than one part to your remainder, just always write it as plus and then out of the original. If this had been a negative 3, you could have done minus 3 over x squared minus x plus 1. But I always just recommend doing plus and keeping this negative so you don't forget a sign. Okay, here's the one I'd like you guys to try. A little bit simpler problem. And Trace, I might pause the video while you guys work on this. Here we go. So for this problem, I already have it set up here. This time we're just dividing in a binomial. So we're doing 2 terms into 2 terms, and our first value will go above the second term. So the question then we ask ourselves is x times what is 4x squared? What did you guys put? Taylor, what'd you put?
4x?
Yeah, 4x, good. So this should be a 4x, so then you multiply, you get 4x squared plus 4x, and then subtract with those parentheses, and then find the difference of those values. So these cancel, but 3x minus 4x is a negative 1x, and then you pull down the negative 11. What then needs to go here? So So negative 1, whoops, not my highlighter. Negative 1, so then you get a negative 1x again, and then negative 1 times negative 1 is a negative 1. Subtract, find the difference. This is where it can get tricky because you have a lot of different subtraction symbols going on, or negatives, but these cancel. Negative 11 minus a negative 1 is plus 1, so that's a negative 10, and that's your remainder. So the way you would format your solution here is you would say, okay, this is equal then to 4x minus 1 plus your remainder of negative 10 out of the original x plus 1. And there we go. Okay? All right, do we have any questions? Because I don't have any other examples of long division. I was now going to move on to synthetic division for you guys. So this one, ask any of the kids in pre-calc. This one sounds a little weird and abstract, but it's actually a really slick process. You will use this more than long division in future math classes. So synthetic division actually pops up quite a bit in higher math for those of you who choose to pursue pre-calc and calc. And it can be a really efficient way for performing division. But the catch is this, synthetic division is only possible to function as a shortcut when you're specifically dividing by a binomial. So the only cases where synthetic division is used is if you're doing division specifically by a binomial, and kind of like how we've talked about algebraic notation with transformations, they say it's by a binomial like x minus k, where you actually end up pulling the opposite of your k value. So we've kind of seen that be a trend this year, that you use the opposite of k as the divisor. And I know I left a lot of words up here. Part of that is just because it's a little bit easier to not have to rewrite them again and again, but I'm gonna walk through what these steps mean. You can see the example we're gonna use is negative x cubed plus 4x squared plus 9 divided by x minus 3. That is clearly division by a binomial, which is why this works. So the binomial in this case is x minus 3. And if we're saying that if it's division by something like x minus k, you're going to be pulling the opposite of what you see there, meaning your k value in this case will be positive 3. Because of the formatting of it being subtraction in its generalized form, that means the k value itself was a positive 3. So that's what I mean here, that this is going to be a k value of positive 3. That idea of taking the opposite of k. So how on earth does this work? Well, just like we did with long division, okay, before we even get to these steps, you need to first make sure that both your dividend and your divisor descend by degree. Do we see these things perfectly descending by degree? Malachi, you're shaking your head. What's missing for the first one? The x term, right? So I'm going to adjust that to add in what's missing. So this really should be negative x cubed plus 4x squared. We're going to add in that 0x term plus 9, and then that's being divided by x minus 3. So I'm going to pay close attention, make sure those things descend properly. And now we have to get the setup for this done. So we're actually not even to the steps right now. I'm just going to zoom in here so you guys can focus on the problem itself. To set up synthetic division, we actually only perform the math with the coefficients of the terms. So if we look at adjust the dividend, paying attention to our coefficients, this is a coefficient of negative 1, this is a 4, this is technically a 0 term, and then we have a constant value of 9. Here's how this is going to work. I'm going to draw this funky open box like this. I'd like you to do that on your paper. And then I'm going to carry down my coefficients from the dividend into the top of the box. Negative 1, 4, 0, and 9. So notice there's the negative 1, there's the 4, there's the 0, there's the 9. Our k value, 3, is going to sit outside. So k was pulled from that binomial 3. That's the setup, okay? Again, it's synthetic division. We're basically simulating division in a much shorter process. Now I can zoom out a little bit so you can see the steps that we're going to take to do this. So step number 1 says carry down the first coefficient. When I say we're carrying down the first coefficient, that means I'm going to pull down -1, and it's going to sit outside of the box. Carry down the first coefficient, pull it outside of the box. It's kind of like the inverted box that we see with long division, right? It's like it's been flipped upside down. So there's some similarity here, but yet it's different, okay? Step 2 then tells us to multiply k by that first coefficient and write the product of those two numbers below the second coefficient. So here's what that means. We're going to take 3, multiply it by -1. So what's that product? -3, and it's going to go right here. So we are multiplying 3 times -1, which is -3, and now it gets written there. So I'm going to try to color code these things. I don't know if that's going to help you. It certainly helps me.
Teachers, please excuse interruption. If you could dismiss the junior high boys basketball team at this time.
Okay, now we're going to add the values from that column and then repeat the steps. So we're going to add these two things together. The sum of 4 and -3 is 1, and then we're going to repeat the process.
Wait, so you multiply k by the first what coefficient?
So you start by pulling down the first coefficient, then you multiply these together, it goes here. Then you add that column, which is 1, and now we're going to repeat the process. So now 3 times 1 is 3, which is going to go below the 0. We're going to add those, get 3. Then we're going to do 3 times 3, which is 9, and it's going to go right here. So 3 times 3 is 9, it goes below the other 9, add those, get 18. And we're done. But you have no idea what we've done. And that's what I want to help you interpret now. So we just simulated division, and to understand our solution here, I'm actually going to go back to this example, okay? This one that I just had you do on your own. Notice this was a trinomial that was degree 2 divided by a binomial that was degree 1. The original dividend was degree 2, the solution was degree 1. It makes sense that it should be one step down because everything was being divided by a factor of x. That means essentially that one power was being taken away from every value, and that's how we then can interpret our solution here. Because this was originally a cubic polynomial, right? That first power was 3, and we divided by a binomial that was degree 1. Our solution then begins with an x squared term. So essentially the solution is always 1 degree less than the original dividend. So these then get transformed into the coefficients of terms that are 1 degree less than their start terms. So that is interpreted as a negative x squared plus a positive 1x plus a constant value of 3. This is the remainder. So then plus 18 over the original x minus 3. And that's your solution. So the solution you could write is always 1 degree less than the original dividend. And that's because you're dividing everything by a degree 1 binomial. Yeah.
What if the x in the x minus 3, what if the x had a coefficient?
They won't. So this only works if it's just the format of x plus a number or x minus a number. Yeah, that's a great question. Okay, so my question to you guys is, do you feel like you're ready to try one on your own, or should I do one more for you? I was thinking maybe do one more and then have you guys try one. Yeah, okay. And I'll do this one a little bit faster because I'm not actually like writing out all the steps for us. I'll do this one faster and then I'll have you try one. So you've got 3x cubed minus 2x squared plus 2x minus 5. We're dividing that by x plus 1. So this goes back to Malachi's question. Notice this x has a coefficient of 1. So that's always going to be the format for synthetic division to work. We also want to check to make sure that our dividend decreases perfectly by degree. In this case, it actually does. But again, from experience and years of teaching Algebra 2, That's one of the number one places I see students make a mistake with this concept, is forgetting to put in the 0th degree term, or the 0 term for missing degrees. So do be conscientious and careful when you do these problems. Okay, so because we're not missing any terms in terms of descending degree, and it's division by a binomial, the first thing I'm going to do is establish for myself that my k value for this is -1. So the value that I'm dividing every coefficient by is a -1 because it's always the opposite of how it's showing up in that binomial. Now I'm going to draw my open upside down box right here, sticking our k value outside. And I'm just going to copy down the coefficients from our beginning dividend. So we've got 3, -2, 2, and -5. And I realize I've been saying coefficients, but the constant is also included here. So we essentially are just getting rid of the variable parts. Okay, setup is complete. Then the next step is to just go ahead and immediately pull that 3 term down and out of the box. So 3 gets pulled out. Then we find the product of -1 and 3, which is -3, and it gets stacked with the -2. Once we stack those, we add them, and we get -5. Now we repeat that process. So now -1 times -5 is a +5, which goes below the 2. Add those together to get 7. Finally, -1 times 7 is -7, which goes below the -5. Add those together and you should get -12. So before I format our solution, do you guys have any questions on those steps? Just on how I got those values? Okay, then because the original problem began as degree 3, our solution is going to begin as degree 2. So this is 3x squared minus 5x plus 7 plus a remainder of -12 out of the original x plus 1. And there you've got your answer. So it's pretty slick once you actually get the hang of it. But I know it's a foreign process for us right now, so it might take some time. Any questions before I have you try one on your own, Ben?
Could you just do -12 over x plus 1?
Yes, you could. Mm-hmm. Okay, here's the one I want you to do. And then we're in the home stretch. Here we go. For this problem, you do have to double check that your values descend perfectly. This one does not. You would have needed to insert a 0x squared term. So as you set this problem up, here's what it should look like. You should have a -3 out here because we take the opposite of our k value, right? And then you should have a 2, a 2, a 0, a -1, and a -7. So first thing, just look at your paper, make sure you set it up right. That's honestly the most important part, because if you miss that 0, it messes up the rest of your answer. Then the 2 gets pulled out and down. -3 times 2 is -6. That gets stacked with a 0. We add that column, and you get -6. Then -3 times -6 is a +18. Add those together to get 17. And then -3 times 17 is a -51. And so when you find that sum, you get -58. So your solution here should be 2x squared. Again, it started degree 3, so we're descending down and starting with degree 2. So 2x squared minus 6x plus 17 plus a remainder of -58 over the original x plus 3. Or you could have done minus 58 over x plus 3. But there's your answer. So I have one last little kind of addition to teach you to this. It's just one example. I don't even have one for you guys to try, but it will pop up in your homework. What you guys will find, because in my opinion, Algebra 2 is kind of the class that's like at the threshold of much higher math. You're kind of at that stepping stone to learning more and more complex content. A lot of math, like when I went and got my degree in school, was all just based on different theorems and postulates that you prove. And I know you guys just came to me from geometry, and I know you did proofs with Mrs. Hecker, correct? Maybe not everybody's favorite thing. I'm not going to show you a proof today. I'm just going to show you one theorem that has been established from synthetic division, and that is called the remainder theorem. So again, for those of you who choose to pursue engineering, or honestly, there are lots of different degrees that would require you to take higher math in college, you'll encounter more and more theorems. This theorem basically tells you an additional application for the remainder that comes from synthetic division. Now I want you to look at how this problem is formulated. It says evaluate the function. So this is the first time we're seeing a function. We're not just given a polynomial expression. It says evaluate the function f of x equals 5x cubed minus x squared plus 13x plus 29 when x is equal to -4. Now, I'm well aware you guys could just take your calculators. You could put -4 in for your x values and find the output. But that actually can also be found using synthetic division, which when you get into higher and higher, or more and more complex functions, I should say, this actually might be a helpful tool for you. So that's what I'm gonna show you next. Because this is formulated differently, we're told x is equal to -4. We're not actually given the binomial. This then can be interpreted as your given k value. So this is your k value, meaning you don't actually need to take the opposite. It's already been done for you. It's essentially like saying for this synthetic division problem, k is -4, meaning it's coming from a binomial of x plus 4 because it's showing up as negative. Now, if you then perform synthetic division for this problem, again, I understand that it's asking you to evaluate a function, so you might not yet see how this applies. The -4 is just gonna go out here, and we're gonna pull the coefficients from the function that we're given. Also checking to see that it descends perfectly, which to me that does. It's 3, 2, 1, and 0, so we should be good to go here. So we're gonna copy down the 5, the -1, the 13, and the 29. Now we'll real quick perform our synthetic division, and then I'll show you what that actually tells us in terms of this theorem. Pulling down the 5, -4 times 5 is -20, finding that sum is -21. Then -4 times -21 is a positive 84. We're getting into higher numbers. Adding those together, that's 97. And then, yes, I would anticipate you need your calculator for this, but -4 times 97, I'll tell you, is -388. And when you add that column together, that value is -359. Now, this problem didn't ask you to perform division by a binomial, so we're not gonna take this and interpret it as 5x squared minus 21x plus 97, etc. Instead, this is what the remainder theorem states. What it tells you is that the remainder from your synthetic division, which in this case is -359, is actually the output value of that function for an input of -4. Meaning, we can therefore conclude that if you had taken -4 and put it into the function, the output for that would have been -359. And you could check that. You could go into your calculator and you could actually put in this start function, replacing your x values with -4, and you're going to get an output of -359. So it's just kind of a unique little application for synthetic division, that synthetic division can be used to evaluate function values for given inputs using that process, which can be pretty efficient once you guys actually get it down. Okay, Trace, you can probably at this point pause the video for the guys. Do you guys have any questions? Your homework's really just gonna consist of those 3 things, so